Hi, this is Rachel. This is the partial fourth grade content video. The focus is going to be on the physical and life science. So in fourth grade, this is the paragraph at the front where it talks about the content that will be covered and also some of the specifics about what we expect that fourth graders will be able to do. Now these audios focus on the content, so we're not going to be doing Earth science, so we're not going to do stars and planets or motion of the Earth or weather charts and water cycle. We'll come back to those. But for this one, we're going to be looking at light and sound, balanced and unbalanced forces, and energy in an ecosystem and how organisms play roles in communities. So this is the Georgia Standard of Excellence about light, and it's very similar to the one that was in the Georgia Performance Standards. The vocabulary is the same: opaque, transparent, and translucent. So as a teacher, you should know those terms, and I'll go over those in the next slide. And also about mirrors and reflection. And C is about refraction. What you'll see missing here are lenses in particular. Previously, there were concave and convex lenses, and I think those were pulled out because it was really hard for teachers to get their hands on those types of lenses. And also those lenses work best with something like a laser pointer, and those maybe not thought to be very safe in the classroom. So what's left are prisms, and you should have some prisms around. You can also use a lot of different things can refract or bend the light, including something like an old CD. So here's your content. So there's kind of two big themes in fourth grade, which is energy. I think when we look at light, sound, and motion, we're really looking at energy, and also ecosystems energy, so we're kind of on the energy side of things. When we get to the solar system, you're looking more at patterns, although the sun is a big source of energy for our whole Earth. So I think the focus here, you can really start to talk about energy, and energy in its simplest form is the ability to cause change. So light is a form of energy, sound is a form of energy, motions are a form of energy. So this idea of energy is a little bit vague, but also when you see change happen, it means that there's been some energy. And one of the things about light that is a misconception is that we can see even without light. In fact, if an object is in a very, very dim room and we can see something, it means there's a little bit of light. And we talked about this earlier in some of the earlier grades, but this is going to come back again. So we want to make sure that we're not getting any misconceptions about light. So the new concepts are what light does through materials, and we're bringing in the vocabulary, and that's in 4. And then again, we want to talk about something emitting light, which is giving off light, which are very few things. The sun is the major one, but also light bulbs and fireflies or a candle. Those are things that emit light, and everything else is reflecting light. And some objects reflect light very, very well, like a mirror, so it'll look like it'll come back to you in the same way that it hit the object, and so it'll look like the object itself. That's what a mirror is. Or sometimes it scatters, and everything that you can see around you is a version of scattered light. If it's not emitting light, it's reflecting light, and that reflecting light can either be scattered, which is what most things are, like a table or a desk or a person, and reflecting light just kind of right back at you, which would be any kind of shiny surface. And this is actually a repeat of some of the earlier grades. So some of the things that are changed are just a little bit this addition of mirrors and this addition of refracting and reflecting light. So just so you know these terms, we have opaque, which means that the light can't pass through at all. Translucent, which is some light passes through. And transparent, which is all the light passes through. So in this image, we have a wall over here, which is opaque. We have some windows over here, which are transparent. And then we have some examples of translucent. So some of the light is passing through. One of the nice things about this is it kind of shows form and function. We have reasons we might use opaque materials, translucent materials, and transparent materials. So that's a really nice real-life phenomenon that you can explore with the students. Refraction is the bending of light, and the two common examples which are talked about in the standards are through a prism and through water. And so whenever we see light bent, we're going to see an effect. And so in refraction of this, it's going to look like the pencil is not in one straight line. And then in this, it's a little more complex, but we have white light going through here, And because of the nature of white light being a mix of all these different colors of light, as it goes through the prism, which is designed to do this, what will happen is the light will refract at different speeds, and so it comes out not in one big piece of white light. It comes out separated into its different parts. And that's what a prism does. And I tried to find some good images online or some videos, but they're really, I think it's just very individual, and you're going to find what you want to find as far as these examples. But prisms are really, really fun and cool. They work best in sunlight. They don't work as well with regular flashlights now because flashlights tend to be LED, and LED lights don't have all the spectrum. So the best thing you can do with refraction with a prism is to use sunlight so you see all of the visible colors. And so I think one of the things that is kind of hard about a prism is we talk about white light being made of these many different wavelengths of color, and we're like, it's kind of hard to see. So I sometimes think the reverse is actually easier, and I don't know if this will come up exactly. You might have to see a little bit of a... But anyway, this is the classic. When we go ahead and we put lights together, then you're going to go ahead and see that they turn into white light. So we can see that when we put the colors together, they become white light. So that's kind of I think a really nice way to show that white light is composed of many different colors of light. These aren't on all the colors, but it gives you the right effect. And then reflection. So there's reflection, which is on a shiny surface, which would classically be something like a mirror or a lake, or again, just everything else that we can see is reflection of light off an object. Without light, we cannot see anything. Light has to enter the eye. So then we can go ahead and we can move to sound. And sound and light are together because they are both through wavelengths. And probably the two things that are a little bit confusing about sound are vibrations and then also what pitch and volume are. So in this case, we haven't really talked about pitch and volume. But if we talk about the speed of vibration, so first of all, vibration is just how fast something moves back and forth. It's not how fast it's not how fast the sound takes to get to you. How fast the sound takes to get to you is dependent on the medium and whether or not it's going through air or water or a solid. But the up and down motion of the vibration, the speed of the vibration, is what we talk about when we talk about the kind of sound that you have. So the faster an object vibrates, the higher the pitch. And the slower an object vibrates, the lower the pitch. And that's really different from how loud something is. So pitch is how high or low the note is, and that's how fast the vibration is or slow it is. Whereas the height, like the up and down, not the speed of how far it's going up and down, but how high up and down it's going, the height of the vibration, is going to determine how loud or soft something is. So if we have something that is something vibrating very slowly but very high up and very high down, then it's going to be a loud, low note. So I have a couple of images to show you. Let's see, this is about pitch and volume, just so that you can kind of make sure you have a sense of it. So I think that's a good resource for just helping you remember that pitch and volume are different. If you're a singer, this is not something that's difficult for you, but I have found in my observations of undergraduates that this pitch and volume concept is a little bit tricky, so I thought I would go over it. And I think, let me see, let me go back here to, I'm going to go to home. I want to just put this on and show you a violin because This is just a common musical instrument, and we talk about the vibration of a string. So you see the vibration of the string on the violin. So we talk about that. That's like going back and forth. That's what we want to see. So the vibration is the back and forth. It's not talking about how fast the sound takes to get to you. It's talking about how fast back and forth the string is moving, and is it moving back and forth, the speed of the back and forth, and also how high up and down it's going back and forth. The speed of it going back and forth again is pitch, and how high it's going back and forth is going to be volume. That's called the amplitude, which is like the height of the wave, the height of the wave. Yes. So, coming from here, we have these ideas. And then this is the content just in words, which is, again, sound is a form of energy. It has to do with vibrating objects. And then we want to look at the speed and the volume. So the speed is the pitch, and the amplitude, the size of vibration, is the volume. So the next part is balance and unbalanced forces. Now this is I think a lot of this is not intuitive about balance and unbalanced forces. And I was looking for a number of pictures to show you some concepts, and I really just couldn't find them. So I'm going to describe a couple things that are important to do. One we did in class, which is dropping objects of different masses and seeing if they land at the same time. That's just about understanding gravity. But the other one is about A, which is understanding that if an object's not moving, that's a balanced force. Or if an object is moving, this is the part that's not intuitive, if the object is moving at a constant speed and a constant direction, so if it's going the same speed, 60 miles per hour west, it is a balanced force. So it's only when you have a change in speed, like slowing down or speeding up, or a change in direction. So a change in direction is also an unbalanced force. So for example, if I'm going down a ramp at 60 miles per hour, but that ramp is turning, I still have an unbalanced force. So anytime we have a change in speed, which is slowing up or speeding down, or a change in direction. So I could have just a change in direction, and I'm still having an unbalanced force. Or I could have a change in speed, but still be going straight. Again, I have an unbalanced force. So understanding what balanced means doesn't mean not doing anything. It means that it's moving at a constant. The constant could be 0, but it's a constant speed and it's the same direction. It's not changing. If we have anything changing, that's an unbalanced force. And that's the key to understanding them. And there's what I was looking for online, couldn't find, but you can do it at home yourself, is you just put a ball, any kind of ball, like a basketball or a tennis ball, on a wagon. And if you're pulling the wagon straight, the ball will stay on the wagon. But if you turn the wagon, what you're going to see is the ball wants to continue going straight because it doesn't have that force applied to it yet. You've applied it to the wagon, but not the ball. So the ball is still going to maintain its straightness and its speed. And that's the other thing that's not intuitive, is that once you put a force on something, a force is what changes something. So if we have an unbalanced force, then we're going to see a change in speed or direction. But once you've applied a force, an object will keep moving in that constant speed and direction unless you apply another force. And that's one of the least intuitive things. And what that means, if I were to start rolling a ball down a hill, not a hill, that would be bad. Rolling a ball in a straight line, not going up or down, it's going to go on forever if there's nothing stopping it. Now in the real world, there's always something stopping it, and that force stopping things is friction. Friction always stops something from moving. It always goes opposite direction. But this is the idea that we could send things out into space and they're going to keep going on forever because there's no friction out there, because there's no matter. So once we go and we set them in a straight line and we apply the force, it's going to keep going in that same direction at that same speed until a different force is applied. Now what we see in the real world is that there's always something that's going to slow down, and that's because, again, we always have friction. But if we can imagine that we put something on the longest piece of ice that you can find. So when we go ahead and we push this, so we push a hockey puck down a piece of ice, it goes really, really far. And if we can imagine the ice has a little bit of friction, but imagine the ice had no friction, we kind of just visualize that that puck is going to keep going on and on and on forever because there's nothing to stop it. So that's kind of like imagining ice and imagining just ice to the extreme where we have none, instead of just little friction, no friction. That's why something's going to keep going. An object will only change its direction and speed if another force is applied. So that brings us to, A, and then B, gravity is a force, understanding that gravity acts on objects and it makes them change unless it's balanced by another force. But we did this in class, and this is super important, understanding that most forces are pushes and pulls, and we did that in earlier, I think, 2nd grade. But gravity as a force is only one that pulls. It does not repel or push. So gravity is unusual, and that is a force that only pulls. It's going to pull something toward it. And the other thing about gravity is that it speeds things up. And that's, very evident when you roll a ball down a hill, that's going to speed up. Or you ride a bike down a hill, you're going to speed up. And so just getting kids to notice that things speed up as they fall is really good. I think that having them understand that they speed up at a constant rate is something I have trouble teaching to undergraduates. So the key is that things speed up when they fall. And if you can do it, showing the blocks where things of different masses hit the ground at the same rate, I think you can do that with a lot of things. I remember you doing it with pens and pen caps and everything like that. So as long as we don't have something like a piece of paper where we have a lot of air, we're catching a lot of air, you're really going to be able to show this very, very effectively. So the effects of gravity on objects. So we talked about A, we talked about B. And then the thing with C is just the idea that I'm not exactly sure why simple machines are so stressed, but they're pretty easy and they're pretty fun. And the idea is that if I go ahead and use a simple machine, it takes me a certain amount of force to move an object usually. But I can use a simple machine and I can change how the force is applied, and that will make it easier for me to move the object. So simple machines are a very practical way for getting things done. And it's not that you do have to use more force, but the thing about simple machines, and this is a little more tricky to explain because it is mathematical and they specifically say don't use math, but you can imagine a pulley is an example of a simple machine. So when you're pulling something straight up, like a flagpole, you have to pull, if you had to pull it up, you'd have to stand at that flagpole and pull up. But it makes it, what the simple machine does, it allows you to change the direction of the pull so I can pull down. And that's one of the ways it makes it easier, just by changing the direction that you're going to moving. So I'm actually pulling down to pull something up. That's a simple machine. The other more common simple machines are we have something where we trade off. I want to be able to use less force to make it easier on myself, and so I actually pull the object a longer distance. And this is a little more complex, but the classic one would be the catapult or the inclined plane. So if we think about something going up a ramp, it's easier to, the classic example is a piano. If I wanted to pull a piano straight up to a second floor, it would be very hard to do. So what I do is I go ahead and I put that ramp there, and I have to push the piano up a longer distance because instead of going straight up, I'm actually going the other side of the triangle. If we can imagine, straight up is like if it's a right triangle, and the ground is the bottom of the triangle, and up is, the wall. And I'm actually going now on the inclined plane, the hypotenuse of the triangle. And again, if you go and you look up simple machines, you'll see what this means. But basically, I'm trading off, I'm moving farther, actually. But because of that, I don't have to use as much force. But the key to simple machines is understanding that they let you use less force to move an object by either changing how far you move the object to get it done, or by changing the direction you have to pull. So there are many, many, many good examples of the 6 types of simple machines, and it's just basically looking them up and seeing what they are. So again, this is something I just said with just words, but just force is a push or pull. So we can read through these things about balanced and unbalanced forces. And then we talk about gravity being a force, which is always something that is a pull. And then simple machines. So that's the key. Again, we're talking about changing things. So we're always talking about, motion is a type of energy. So we've got motion is energy, sound is energy, and light is energy.